4.4 number 8. Okay, calculus 30, 4.4 optimization. Number 8 says, let's get to that textbook and see what it says here. It says this right here. A farmer wants to fence an area of 750,000 square meters in a rectangular field and divide it in half with a fence that's parallel to one of the sides of the rectangle. Okay, so first thing we need to do is we need to draw this. So if we draw this, we have a rectangle, and sorry about the regular rectangle. But the farmer wants to divide it in half with another piece of fence. So here's about half. And the area of this is 750,000 square meters. So you're given some information, the area, okay? That's important. And you know that the farmer wants to use this fencing material, and he basically, because he wants to divide it in half, he's got two lengths right here, right? A length here and a length here. But he's got 3 widths. You see that? Instead of 2 widths, he's got 3 widths. So it says, how can this be done? So to make a rectangular pen like this with this area in total, to minimize the cost of the fence. So basically he wants to minimize the material. Okay? We can do a cost function here. The cost function is going to be 2L, that's 2 lengths, this one, plus 3W. That's what the cost function is going to be. And it doesn't matter what the cost is because it's basically just the amount of material. The more material it has, the higher the cost. So we want to minimize this amount of material. But you see that we have 2 variables, no good. So let's make one variable expressed in terms of the other one. And we can do that by this right here. Now area is just good old-fashioned length times width. See that? So 750,000 equals W times L. So I don't know which variable you want to isolate, which one you want to have left in here. Let's have L left. So let's make W in terms of L. That's 750,000 over L. Does that make sense? This dimension times this dimension gives you this number. So the cost now is going to be in terms of L alone. It's going to be a function now. 2L plus 3 times W is this right here. 750,000 over L. We should simplify this now. We've got one variable, so that's great. We should simplify this because you don't want to take the derivative right now. You may as well simplify this because there's a lot of little things you might mess up on. So C of L is going to be 2L plus, what's 3 times 750,000? Here's your product right there. 225,000. So that's going to be 2.25 million over L. Okay. So this is easy enough. You can now you can take the derivative here. So again, write a formula relating the variables. Write one variable in terms of the other. Do a substitution. Simplify. Now take the derivative. So what's the derivative? 2. And derivative of the top, which is 0, minus the bottom, times the bottom, minus the top times the derivative of the bottom, which is just 1, all over the bottom squared. You're going to end up with negative 225,000 over L squared. And now what we need to do is we need to basically let this equal 0 and solve for L. So you let this equal 0. I've just made this as a common denominator here. So we have 2L squared minus 225,000 all over L squared. Now this here's another little shortcut, you guys. If you have a fraction, like a rational, and you have to let it equal 0, it doesn't really matter what this is right here. As long as this top part is 0, that's all that matters. And how do you know? Because right now I'm going to multiply both sides by L squared to get rid of this L squared. And what does that do? Nothing over here. So I'm just concerned about this top part. Alright? And then you go on from there. So 2, 2, 5, 5 by 2, 5 by 2. 1, 1, 2, 5. And the square root of that then. Square root of that answer is about 1060. Now, I'm not sure if the back of the book, I think that because this is a real life problem with actual lengths of material, you can just use decimals. If it might ask you for exact numbers, then you have to leave it as a root, a radical. But you can round it to decimal for most of these actual questions. So 1060.66 what I get for L as a critical number. And what you have to remember is now you have to go back to your diagram and say L was the length. Right? So the length here, and to find the width you do 750,000 divided by L and you get the width. And that's the W part that he's using here. So W, thank you, is 750,000. So the width equals 707.11. There are your dimensions. The question, go back to the question always. It says, how can this be done? Well, you would then just say that if the length was this many, meters, and the width is this many meters, that's how you can maximize your area using that amount of material. This is the amount of material that you need. So that's the problem. 4.4 number 8 worked all the way through, and there should be your answer.